All right, we're going to do number 9 here because yesterday I told you I was going to use unit circle all the time. But when I'm doing tangent and cotangent, I'm going to make triangles. Okay? So something we need to know is that tangent is equal to a y value over an x value. Hopefully we had that up yesterday, so I hope you all know that. And I'm going to make I'm going to solve this thing for tangent, and I'm going to find a y and x. And then I'm going to make triangles that are not in the unit circle. It'd be a different size, and I'll explain that in a minute too. So the first thing I'm going to do here to get tangent by itself, everybody yell it out. What do? Subtract 1. That wasn't everybody. That was about one person. So I get radical 3 tangent x equals -1. And then everybody, what do to get rid of the radical 3? Divide by radical 3. So I get tangent x equals -1 over radical 3. Okay, now there's something we got to know about fractions that are negative. Now this one, I got the negative with the 1, right? But there's a rule about negative fractions that you can change where the negative sign is and it doesn't change the value. I've got it in the numerator. Everybody, where can I put the negative? At the denominator. So I'm going to also say, hey, this also equals 1 over negative radical 3. You can also put it at the fraction bar. Okay, you can put it in front of the fraction bar, but the problem with that is you need the negative with one of the numbers to draw all the triangles you need. Okay? So again, from this thing up here, we know that tangent is y over x. So up on this one, y is +1, x is negative radical 3. On the original one, on the first one we did, y is -1 and x is positive radical 3. So that means there's 2 different triangles that will work for this. So let's think about this. We're going to draw our axes. So this is the x-axis, this is the y-axis, and we should have done a different color. I think we want to. Oh my gosh, I don't want that. Let me draw a different color because I'm going to do one in blue and one in purple to go with the correct triangles. All right, so I got a y-axis and I have an x-axis. So let's do the purple one first. What quadrant is x a positive and y a negative? Anybody tell me what quadrant x is positive and y is negative? 4. So I'm going to draw the purple triangle in the 4th quadrant. Okay, so let's do this. Y is -1. Which one of the legs is the y? Is it the horizontal leg or the vertical leg? Vertical. Everybody's free to jump in here and answer. So this is -1. And x, is x the horizontal or this side? I hope y'all know what the side opposite the right angle is called. What's it? Starts with an H. Hypotenuse. Hypotenuse. So this is radical 3. Now you can do Pythagorean theorem to find the hypotenuse right now. Okay, but you should know that if you've got a side that's 1 and a side that's radical 3, that's one of our what kind of triangles? What your grandmas all think about you? Special. That's right. You're all special. But it's a special triangle. So you're supposed to know that when you got a 1 and a radical 3, the hypotenuse is automatically 2. Now you can do Pythagorean theorem and get 2. Okay? So now you got to remember what angle is opposite to 1 in the specials. Does anybody remember what special triangles you have when you have a 1, a radical 3, and a 2? What that special all 3 angles are? I got one up there with a box. We know that's a 90, right? Anybody remember what the other 2 angles are that go with a 1, a radical 3, and a 2 from the specials? Somebody guess. Worst you can do is be wrong. 45, 45, 90. Okay, well, let's look at that because that's another special. That is a special. So you guys learned this in geometry, and we talked about it again earlier. If these 2 angles are the same, what do you know about the sides opposite equal angles in a triangle? They're the same. You remember that? So that means that whatever this side is, this side's the same as that one. Right? They're equal, and then you're supposed to take a leg times radical 2 to get the hypotenuse. So would that be the right one? No? What's the other one? 30, 60, 90. So this is a 30, 60, 90. Does anybody remember which angle is opposite the 1? 30 is right. Now here's another way to remember. You guys had triangle inequality theorem back in geometry. You ever heard of that? The triangle inequality theorem basically says that the biggest angle is opposite the biggest side. So since hypotenuse is big, it's 90 is your biggest angle. Then the smallest angle is opposite the smallest side. Do you guys know what radical 3 is approximately? Do you know that one? Have you hit it on your calculator enough to know it yet? 1.414 is radical 2. 1.732, okay? So, which is bigger, 1.7 or 1? 1.7, right? Right? So, if you think about it, you could put a radical around 1 and think what's bigger, radical 3 or radical 1. I hope you would all know radical 3 is, right? Because the square root of 1 is 1, so it's the same value, right? So 3 is bigger, 1 smallest, so that tells me that the smallest angle, the 30, goes over here. And the 60 goes down there. Okay, I'm going to do this next one a little faster, okay? Because hopefully we got the idea. We're going to do the blue one. My next question for you is, where is x negative and y positive? What quadrant is x negative, y positive? It's quadrant 2. So I'm going to draw the other triangle up here. And again, the x is horizontal, which we got right here is over here is negative radical 3. This is 1, so this is still 2 because it's staying special. And that 1 means that this is a 30-degree angle. We really only need the reference angle here. Okay, we're almost to where we got the answers now. So what I need to know now is, what is the angle measure starting at 0 coming to here? This is what we did a long time ago. This is my first answer. So does anybody remember what you have to do to find, this is your reference angle. If you remember the words, this is your angle, theta. What did we do in the second quadrant to find the red angle arc? Anybody remember the second quadrant what we do mathematically? That's right. Over here is 180, right? Over there is 180. This is 0. So we go to 180 and back up 30, which is 180 minus 30. So one answer to this problem right here is x equals 150. Because that's what 180 minus 30 is. And the other answer starts here and has to go all the way around to that hypotenuse. Does anybody remember in the fourth quadrant what the rule was to find theta when you had a reference angle of 30? 360 minus 30, exactly. So the other answer that works is 330. Now, can you check those two on your calculator to see if this works for this? Heck, yes, you can. Do I need to show anybody again? You need to see how to check it on your calculator? All right, I'm going to put the picture up there. So give me a second to get that screen up there. Okay, so I need to be able to see this thing right here, this 1 plus radical 3 tangent x. What's your mode got to be in? Anybody remember? Degrees. So you always want to check your degrees. Anybody here does physics use degrees most of the time? Because in calculus, we always use radians. Okay, so there's my calculator. So to check degrees, you hit the mode button right under window. And mine's already in degrees. See it right there? The degree is highlighted right there. So I'm already in degrees. So I hit second mode. It's quit that screen. And I still got the one I checked yesterday up there. It's those two right there we checked in class. But now we're going to check 1 plus radical 3 tangent. So I'm going to put 1 plus, and I hit second x squared, which is radical. I hit 3. Then you have to arrow right to stop the radical. And I hit tangent. And what's one of the answers we got up there? So I'm going to type in 150. And then I'm going to hit enter. Hey, it's supposed to equal 0. If you look at the equation right to the right of my finger, it's supposed to equal 0, and it does, so I know that one's right. Does anybody remember how to get that exact thing to come back up without having to type it all in again? Second enter. And then I'm going to go back and change 150. What's the other answer I got? I got 330. And I hit enter. Hey, I got the answer they told me I'm supposed to get again. So I know I got both of those right. Now, it is possible there are more that worked if I screwed up and didn't write all the possible answers down. I did not do that on this, but it is possible that you can have more answers that will give you 0. So you got to think about all the way around the unit circle, all the places that work. Remember yesterday we had a couple that had 4 answers? There's some that only have 1 answer. There's some that no answers work. You want to see a no answer problem? Okay, I'm going to give you a no answer problem real quick, just to show you, and I'm going to go ahead and put it on the screen because every once in a while you get one crazy like this. So they may have a problem that says this, and I'm just going to put a new screen up to show you, and I'm going to explain to you why it doesn't work. So they have like sine x minus 2 equals 0, and I saw this for sine x equals 2. Let's see how to get that. Why or how do I know that doesn't work? There's actually more than one way to know it doesn't work. This answer is no solution. How do I know that's no solution? Good here. Okay, sine's which value? Sine of which value? Yeah, there's no y value for sine that equals that. Y'all remember graphing sine? Okay, let's talk about the graph of sine. Here's one reason it doesn't work. Okay, one reason it doesn't work. If you remember, we always went out to 2 pi, and then I always cut it in half to pi. Then I cut this one in half to 3 pi over 2. And I cut this one in half to pi over 2, and I did the same thing on the other side, but we're just going to do one period, so I'm going to put it there. Where does sine always start when you graph it? It starts at the origin. What did it always go up to the highest? 1, and down to -1. So when we graph this, we started at the origin, we went to a max, we went to a 0, we went to a min, we went to a max, and then it continued that thing forever. Remember? You guys remember doing that? What's the biggest value sine can equal? 1. What's the smallest? So if you ever have sine or cosine equal a number that is greater than 1 or less than -1, the answer is going to be no solution because there's nowhere that works. And if you think about the unit circle, another way to know it doesn't work, if you think about the unit circle, the biggest y value is 1, and the smallest y value is -1. Remember, pi over 2 is 90, and 3 pi over 2 is 270. This is the biggest y, this is the smallest y on the unit circle. That's another way to know it doesn't work, because the unit circle only goes to there. Does anybody remember how this could change? What changed? What made my graphs go up higher and down lower? What's that word? Starts with an A. Amplitude. And where did the amplitude number come from? It was in front. It was in front here. You remember that number in front of sine is amplitude? So if I had an amplitude of 2, how would that change? Well, that means this would no longer equal 2, right? Because we have some that have bigger amplitudes. So we would be done solving this for this kind. So then we would divide by 2 and get sine x equals 1. Is it possible for our sine to be 1? Yeah, that's the biggest one, and that happens at 90. So you see how it changes if you have an amplitude that's not 1? Okay. All right. Anybody else got one they want me to do? So number 15 on the sheet says 4 tangent x minus 5 equals 5 tangent x minus 4. Now I'm gonna rewrite this for algebra. What if it would have said 4x minus 5 equals 5x minus 4? Tell me, what would you do? What would you do? What do you notice about your x's in the equal sign? What do you notice about x's in the equal sign? Where are the x's in comparison to the equal sign? They're on both sides of equal, right? So we want to get all of our like terms what? Get them together. So what I would do is I would have taken and subtracted 4x here, and coming over here and subtracted 4x there, and then I would have negative 5 equals x minus 4. And then you want to get the x by itself, so you would add 4 and add 4, so I would get x equals negative 1. Do you remember doing that in algebra? Get your like terms together? Okay, well, let's go over here. What do you think we would do with it when it says tangent? That's right, we're going to get our like terms together. We want one tangent, we don't want two different tangents on two sides. So then we would get negative 5 equals 1 tangent x minus 4. Then what would we do? We would add 4, and we would add 4. Oops, I don't know why I put a fraction bar there. And then we would get tangent x equals negative 1. Can you finish it from there and find where that's true?
Well, I still have problems with and finding which.
Okay, this is a tangent. Do you remember what I just said about tangents? Huh? Yeah, remember I did a tangent here? So the first thing I want to do is make negative 1 into a y. I want to make this into a fraction, so what can I do? Put negative 1 over what? 1. And I could also write this as what over what? But still equal. What? That's right. Move the negative down to the bottom. So that means I'm looking for 1. Whoops, let's do blue or purple there. Y equals that, x equals that. And then for the blue one, we're also going to make another triangle, just like I did a second ago, and see if you can find that. You can do the unit circle. You want me? Oh, I forgot to show you how to do it on the unit circle. You ready? Okay, so I'm going to show you first on the triangles. So where's x negative? Oh, let's do this one first. Where's x positive, y negative? That's down here again, right? X positive, y negative. And then over here, where is x negative and y positive? That's over here again. So this is negative 1 and 1. Does anybody know what my hypotenuses are going to be? Radical 2. This is a special. 45, 45, 90. Radical 2 here. Radical 2 here. Does anybody remember what these angles are? 45s. These are the reference is what we need. And so we're going to get 1 there, which is going to be 135 degrees. And then this one right here is 360 minus 45. That's 315 degrees. And we just did that whole problem. That's the answer to 15. Now, unit circle. If I'm doing that, and I forgot to do the unit circle on the other ones, I did start the video on this, didn't I? Okay. So what I got to ask myself is, where would I have an ordered pair that if I took y divided by x, I would get a value of 1 or negative 1? If I took y divided by x on the unit circle, what do x and y have to be in order to equal 1 when you divide them? They got to be the same. So the places they're the same are right here at 45 degrees. Over here at 135 degrees. And again, this is another reason that if you know your unit circle, it really helps out. Down here at 225 degrees. And over here at 315 degrees. Should have put it in here. And then you're going to ask yourself, hey, which one of these is going to give me negative 1 if I take the y divided by the x? And I hope you see these up here would give you a tangent of x. So in other words, the tangent of 45 would be positive 1. So I take that divided by itself 1. Same thing down here. The tangent of 225 degrees would be positive 1. You see what I'm saying? How I'm getting that? And then down here, if you take that divided by that, the tangent of 315 degrees is negative 1, and the tangent of 135 degrees is also negative 1 when you take y divided by x. You see where that comes from? So the problem is when you have one that's like at 30 degrees, let's say it's 30 degrees here on the unit circle, And now you got radical 3/2½. So if you want to get the tangent of 30 degrees, you would have to take 1/2 divided by radical 3/2. Because it's y/x. We all okay there? So now I got to simplify this crazy fraction here. So that means I need to multiply the top part by the reciprocal of the bottom part. Remember, you flip the bottom over. Hope you know those 2's reduce. So I got 1/3. And then you have to rationalize it. So we move the radical 3 up and take the 3 out in the bottom. This would look like on your problem, it would have said tangent theta equals radical 3/3. And you got to find that, although they probably have x. You have to find that. One of the answers here, one of the answers for this, if it started like this, would be theta equals 30 degrees. There is another one that works. Okay, there's another place that if I made this a negative over a negative, isn't that still positive? So the other one that works is right down here in this third quadrant, where they're both negative. Okay, so that would be 210 degrees would also work if it started like that. So if you think about it, I hope if you think about it, you can see on tangent it's way easier to make triangles to solve it like I did on the first 2 times than to use the unit circle, because you got to do fractions and divide fraction by fraction. You see that? The ones aren't bad. The ones are easy with tangent, but the ones that aren't ones, they're a pain in the rear. All right. What I'll let you do right now is start doing your homework. Okay, so we're trying to solve this for number 20, just secant x by itself. So I'm going to rewrite it and this x. So the first thing, like you just said, was we would divide both sides by 2, and we would get x cubed equals negative 64. So what do you think we do first over here? We divide by 2. So we would get secant cubed x equals negative 64. That's where we'd start. The same math rules never change, man. That's why I love this stuff. So, how do you get rid of a cube? No, not cube it. Cube root it. Cube root it. So what we would do over here is we would take the cube root of this divided by the cube root of that. So we would get x here. Okay? Now some people have a hard time knowing, but if I take a negative times itself 3 times, that's what a cube root means. You need 3 of them to take 1 out, right? And you don't, if you take negative 2 times negative 2 times negative 2, isn't that negative 8? Right. So if I'd have the cube root of negative 8, and it would equal the cube root of all 3 of these, and since this is a 3, we need 3 the same to take 1 out. That means the answer would be negative 2 for that. The cube root of negative 8 would equal negative 2. Y'all remember doing that kind of stuff? So we basically got to find out what number times itself 3 times gets you 64. Does anybody know it? If you don't, we'll do it the long way. Huh? Negative 4 is the right answer. If you take negative 4 times negative 4 times negative 4, that right there will give you negative 64. So this whole thing equals negative 4. Likewise, if you cube root this and you cube root this, we get secant x equals negative 4. It's kind of a good thing we did this one because this is not a special. Now, I don't want to use secant. I want to change secant to what? Cosine. Reciprocal of secant. Cosine. Now, how do I make negative 4 a fraction? So that means secant x will be negative 4 over 1 when cosine x equals negative 1 over 4. This is a good problem that we did this. This is very good. Now, where on the unit cosine? Is it x or y? X. Where on the unit circle is there an x value that equals negative 1/4? There isn't. You know what that tells me about this one? It's not a special. So we got to use our calculator. Are we ready? All right, so we're going to use our calculator. Now, these are tricky. So I need you to do it with me. with your calculator, and then we're going to talk about, because these are kind of the hardest problems to do right here. Let me move this thing over so we can, I'll put it down here. All right, so, okay, I guess I still got to do a little more math. How do I get x? How do I get rid of cosine to get x by itself? What gets rid of a cosine? Anybody know what undoes cosine? What is the opposite of cosine? What? Okay, that's reciprocal. Just like the opposite of multiplying by 2 is dividing by 2, the opposite of adding 2 is subtracting 2. There is an opposite function of cosine. Look on your calculator at the cosine button. Now, what do you think it might be? Okay, that's called the inverse of cosine. The inverse of cosine. So what you literally do right here is we take this side, oh, come on, black, get on there we go. We got cosine -1 of this thing, which means, again, you have to do the same thing to both sides, so we have to do inverse cosine of -1/4. This inverse and this cosine cancel each other out, just like multiplying by 2 and dividing by 2 cancel each other out. So x is going to equal the inverse cosine of -1/4. So I have to get my calculator to do that. So whenever you're finding an angle, you must hit, and I'm going to hit second, and then I'm going to hit cosine, and then I'm going to put in -1 divided by 4, and I get that angle. Now that is in degrees. Now if you look at the directions, what's the direction say to round your angle to? Nearest minute. Does anybody remember what we have to do to this answer? What changes it from decimal degrees to degrees, minutes, seconds? Do you remember that? We've done it. So I got to hit second, and then I hit apps, and you see number 4? That's going to change that to degrees, minutes, seconds. Second, apps 4, and you hit enter. Are we okay to there? Yes or no? Okay. So this tells me I'm rounding it to this 28 part, and I look over to seconds. Does anybody remember what the seconds have to be in order to round to go up? How many seconds are in a minute? Does anybody know? 60. So what does this 39, or what does this number where the 39.044 have to be to round that up to 29? Bigger than what? 30 or bigger? Halfway. 30 or bigger. This is bigger. So one answer is 104 degrees and 29 minutes. That's one answer. Okay, now I got to show you that there's more than this that works. Almost every time, as a matter of fact, anytime you have anything other than a 1 or 0, although I guess you got more than one factor, you got more than 2 answers. But these things are going to have 2 answers in them most of the time. So I want to show you what this is telling me. So you need to do a good job of this, and I'm going to put this on video too. I think I started the camera back up. Where's 104 degrees? What quadrant? Quadrant 2. So I'm going to come over here. I'm going to draw a triangle over here. Okay, so this right here, where it's saying is 104 degrees, 29 minutes. It was 29, wasn't it? I'll look real quick to make sure. Yes, 29 minutes. Okay. So this thing right here, see this -1/4 over 4? This is, if you remember, this is x over r. Do you remember that? X over r for cosine? Because this is not a unit circle. So this is -1 and this is 4. I don't really care what the hypotenuse is. Now, we were doing this a little earlier. Now I put the negative with the 1, right? Where else could I put the negative? Where else could I put the negative on this? I could put it at the denominator, right? And remember, this is, actually, I can't do that because r is always positive. I put the 4 in the wrong place, didn't I? This should be the 4 here, my bad. The 4 should have been there. I put the 4 in the wrong place, so fix it. Now, I'm going to do x squared plus y squared equals r squared. So negative 1 squared plus y squared equals 4 squared. So 1 plus y squared equals 16. So y squared equals 15. So y could be a positive or negative radical 15. I kind of did Pythagorean quickly because hopefully you know that well. So that means this side over here would be a radical 15. Now the question is that a positive or negative one? Is it the positive or negative for y in the second quadrant? That's the positive one. So we took care of this one, so the one that's left is the negative 15. So the question we got to ask ourselves, where on the unit circle would x still be negative 1 and y be negative radical 15? Anybody know? What quadrant are x and y both negative in? Quadrant 3. So that means there's another answer down here where this is negative radical 15. This would still be 4. So do you see that we would still have cosine, and the cosine would still be negative 1 over 4 here? You see it? Yes or no? Do we see that? Okay, now these are really hard. Okay, so now I got to figure out what the angle is from here all the way down to there. And this is where something we haven't done yet comes back into play. We need a reference angle in the red one. Can anybody tell me how I can find this reference angle right here? That's right. You take 180 minus 104 degrees, 29 minutes. So we're going to borrow a degree from here and move it over here to minutes. So let's see. This is going to be 31 minutes. And we got 5 degrees, 7. So this is 75 degrees, 31 minutes. This angle right here has to be 75 degrees, 31 minutes. So we got to take 180 plus this. So the other answer that works is this one. So these are the two answers. All right, I'm going to come around and spray.